From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars.
In the 1960s, humans set out to discover what the red planet has to teach us. Now NASA is hoping to land the first humans on Mars by the 2030s. Since the 1970s, scientists have been sending spacecrafts to Mars. Several different types of spacecraft have been sent to the red planet over the years, and they all have different specialties. What makes rovers unique is that they have wheels and specialize in moving around. They land on the surface of Mars and drive around to different spots. And today, we are going to talk about all of the new information gathered by the Mars rover. Let's get started. A Mars rover is a motor vehicle that travels across the surface of the red planet Mars upon arrival. Rovers have actually several advantages over stationary landers. They examine more territory, they can be directed to interesting features, and they can place themselves in sunny positions to weather winter months. And they can advance the knowledge of how to perform a very remote robotic vehicle control. As of today, there have been 5 successful robotically operated Mars rovers: Sojourner, Opportunity, Spirit, Curiosity, and Perseverance. The Mars Science Laboratory and its rover centerpiece, Curiosity, is the most ambitious Mars mission yet flown by NASA. The rover landed on Mars in 2012 with a primary mission to find out if Mars is, or was, suitable for life. Another objective is to learn more about the red planet's environment. One thing that makes Curiosity stand out is its sheer size. Curiosity is about the size of a small SUV. It is 9 feet 10 inches long by 9 feet 1 inch wide and about 7 feet high. It weighs 2,000 pounds, and Curiosity's wheels have a 20-inch diameter. It has been on Mars for more than 3,000 days since landing on the 6th of August in 2012. According to NASA, Curiosity has 4 main science goals in support of the agency's Mars exploration program. 1. Determine whether life ever arose on Mars. 2. Characterize the climate of Mars. 3. Characterize the geology of Mars. And 4. Prepare for human exploration. Now, the goals are closely interlinked. For example, understanding the current climate of Mars will also help determine whether humans can safely explore its surface. Studying the geology of Mars will help scientists better understand if the region near Curiosity's landing site was habitable. The Curiosity rover has been exploring different aspects of Gale Crater on Mars to understand more about this transition from warm and wet to dry and very cold. The latest study gathered from data captured by one of the rover's instruments suggests that Mars actually transitioned back and forth between wetter and drier times before losing its surface water completely around 3 billion years ago. Curiosity has been steadily climbing the 3-mile-high Mount Sharp located at the center of Gale Crater since 2014. An instrument called a ChemCam sits on the rover's mast and includes a high-resolution camera and laser that can vaporize rocks to help the rover analyze their chemical composition. ChemCam has an infrared-colored laser that can heat rock pieces to 18,000 degrees Fahrenheit, which vaporizes the rock and creates plasma, allowing scientists to essentially look inside the minerals and chemicals comprising the rock and peer back into the planet's geological history. The camera on ChemCam was used for capturing observations of Mount Sharp's terrain, which reveals slices of the Martian past as the rock varies. As Curiosity has ascended Mount Sharp, the layers have changed dramatically. The base of Mount Sharp is made of clay deposited by the lake that once filled the crater. Above that are layers of sandstone that still preserve evidence of how they were formed by wind-shaped dunes during drier times. Layers above this reveal more deposits from the floodplain, including when wet conditions returned to Mars. Curiosity's observations reveal that these changes between wet and dry areas were large-scale events that alternated until the planet grew permanently arid. Mount Sharp's climate record has allowed Curiosity to hone in on a time stretching from 2.9 billion to 3.7 billion years ago. Perseverance rover, nicknamed Percy, is a car-sized Mars rover that launched on July 30th, 2020. Confirmation that the rover successfully landed on Mars was received on February 18th, 2021. And as of today, it has been active on Mars for about 61 Earth days since its landing. The robot is designed to hunt for signs of past microbial life, if it ever existed. It is the first NASA mission to hunt directly for these biosignatures since the Viking missions in the 1970s. The rover will collect samples of rock and soil, encase them in tubes, and leave them on the planet's surface to be returned to Earth at a future date. Perseverance will also study the red planet's geology and test how astronauts on future Mars missions could produce oxygen from CO2 in the atmosphere, as this oxygen could be used for breathing and rocket propellant. In addition, a drone-like helicopter will be deployed to demonstrate the first powered flight on Mars. Perseverance will explore Jezero crater near the planet's equator for at least one Martian year, which is about 687 Earth days. And recently, NASA's Ingenuity helicopter took flight on Mars for the first time, and the Perseverance rover captured the entire feed in very sharp video. In the video, you can see Ingenuity beginning to spin its rotors, get them up to full speed, and then lift itself 10 feet above the Martian surface. After that, it hovers, pivots towards Perseverance, and lowers itself gently back into the dust. It has also been doing as much geology as it can, snapping pictures of its surroundings and analyzing the rocks nearby. Already, team scientists have determined that several of the rocks are chemically similar to volcanic rocks on Earth, and that wind and water have eroded some of them. Perseverance will deploy an arsenal of tools including a drill bit, a close-up camera, and multiple chemical sensors to hunt for signs of past life in Martian rocks. NASA even gets the first weather report from the Perseverance rover. The rover Mars Environmental Dynamics Analyzer, or MEDA system, has sent back data on atmospheric conditions that will be used to inform future endeavors. As measurements were received, the rover's team determined that the surface temperature on Mars was just below -4 degrees Fahrenheit when MEDA's system began recording on February 19th. The temperature plummeted to -14 degrees Fahrenheit within a half hour. In addition, the MEDA radiation and dust sensors showed that the crater was experiencing a clearer atmosphere than the Martian Gale crater around 2,300 miles away. The Perseverance rover even found an ancient rock with small cave patterns. In January 2004, two robotic geologists named Spirit and Opportunity landed on opposite sides of the red planet. With far greater mobility than the 1997 Mars Pathfinder rover, these robotic explorers have trekked for miles across the Martian surface, conducting field geology and making atmospheric observations. Carrying identical, sophisticated sets of science instruments, both rovers have found evidence of ancient Martian environments where intermittently wet and habitable conditions once existed. First among the mission's scientific goals was to search for and characterize a wide range of rocks and soils for clues to past water activity on Mars. The rovers were targeted to sites on opposite sides of Mars that looked like they were affected by liquid water in the past. Spirit landed at Gusev Crater, a possible former lake and a giant impact crater. Opportunity landed at Meridiani Planum, a place where mineral deposits suggested that Mars had a wet history. Each rover bounced onto the surface inside a landing craft protected by airbags. When they stopped rolling, the airbags were deflated and the landing craft opened. The rovers rolled out to take panoramic images. These images gave scientists the information they needed to select promising geological targets to tell part of the story of water and Mars's past. Then the rovers drove to those locations and beyond to perform close-up scientific investigations. Since leaving their landing sites, the twin rovers have sent hundreds of thousands of spectacular, high-resolution, full-color images of Martian terrain, as well as detailed microscopic images of rocks and soil surfaces back to Earth. 4 different spectrometers have amassed unparalleled information about the chemical and mineralogical makeup of Martian rocks and soil. Special rock abrasion tools, never before sent to another planet, have enabled scientists to peer beneath the dusty and weathered surfaces of rocks to examine their interiors. With data from the rovers, mission scientists have reconstructed an ancient past when Mars was awash in water. Spirit and Opportunity each found evidence for past wet conditions that possibly could have supported microbial life. Opportunity's study of Eagle and Endurance craters revealed evidence for past interdune playa lakes that evaporated to form sulfate-rich sands. The sands were reworked by water and wind, solidified into rock, and soaked by groundwater. Landing in a crater, Opportunity scored a hole-in-one by finding the mineral hematite, which typically forms in water. Water is key to life as we know it. Yet, acidic water soaked this area in Mars' ancient past, making conditions harder for life to thrive. While dragging a wheel, Spirit churned up soil and found 90% pure silica at home plate. On Earth, this kind of silica usually exists in hot springs or hot steam vents, where life as we know it often finds a hot and happy home. Perhaps ancient microbes on Mars did as well. Spirit also discovered that an ancient volcano erupted at home plate, the rover's final resting place. Together, powerful steam eruptions from heated underground water produce some explosive volcanism. While violent, these extreme conditions can support microbial life on Earth. Are you waiting for more information to be gathered by the cool rovers? Let us know in the comments down below. Make sure you subscribe to our channel and turn on your post notifications so you never miss a video from us. If you like this video, don't forget to give it a thumbs up. See you in the next video, and thank you for watching.